So today we are looking at the second of our two special right triangles. And this is the 30, 60, 90 triangle that we will be looking to see how we find the missing sides of. So for your central question, I want you to answer, how do you find the missing side lengths of a 30, 60, 90 triangle? So before we get into our guided practice problems for today, the first thing I want to do again is look through some explore problems. So the first of our two explore problems, or the first of our three explore problems are, we're given this triangle here. We're given two of the angle measures. Notice we have a 60 and a 90. Well, if we have two measures that are 60 and 90, the third measure is going to have to be 30 degrees in order for these to add up to 180. So 30, 60, 90 is going to be a triangle that will always occur if you have two of the three measures. So anytime you have a 30 or 60, you know that the third one has to be 90, 60 or 90, the third one has to be 30, et cetera, et cetera. So this one here is the 30, 60, 90. This one here is also a 30, 60, 90. And this one here is also a 30, 60, 90. Now, keep in mind, going back to what we've seen before, that the largest side of the triangle is always opposite the largest angle. So anytime you have a right triangle, your largest angle is going to be 90 degrees, which means the side opposite the 90-degree angle, the hypotenuse, is always your largest side. And for 30, 60, 90, the side opposite the 30 is always your shortest side. So what we're going to do here is we're going to use the Pythagorean theorem to find the missing side value to see what that looks like. So remember, the Pythagorean theorem is a squared plus b squared is equal to c squared, where c has to be the hypotenuse. So for this one here, we're going to have 6 squared plus 6 radical 3 squared is equal to x squared. 6 squared is 36, plus 6 rad 3 times 6 rad 3 is going to be 36 times 3. And 36 times 3 is going to give us 108. 36 plus 108 gives us 144. And then lastly, to get x by itself, we're going to square root both sides. And x is equal to the square root of 144, which is 12. For the second problem here, again, hypotenuse must be c. Our hypotenuse here is 8. So we're going to have v squared plus 4 radical 3 squared is equal to 8 squared. So v squared plus 4 rad 3 times 4 rad 3 is 16 times 3, which gives us 48. It's equal to 8 squared, which is 64. We subtract 48 on both sides. We get v squared is equal to 16. Square root both sides. And v is equal to 4. And for the last one here, again, hypotenuse is opposite the right angle. That has to be substituted in for c. So we have 3 squared plus x squared is equal to 6 squared. That's going to be 9 plus x squared is equal to 36. We subtract 9 on both sides. We get 27. Square root both sides to get x by itself. And we get x is equal to the square root of 27, which of course we want to simplify. So if we take that, we end up with x is equal to 3 times the square root of 3, 3 radical 3. So again, I'm going to clear my screen here so that we can just see the triangles. And I'm going to fill in my values here. So we have x equals 12. Here we have v equals 4. And here we have x is equal to 3 radical 3. So just like we saw in the previous lesson, I want to look at the relationship between the different sides of our triangles here. So again, remember, the smallest side is always opposite the smallest angle. So the smallest side of a 30, 60, 90 is always going to be the side across from the 30-degree angle. So here that's 6, here that's 4, and here that's 3. The first relationship I want you to notice is the relationship between the shortest leg and the hypotenuse. So here our shortest leg is 6 and our hypotenuse is 12. Here our shortest leg is 4 and our hypotenuse is 8. Here our shortest leg is 3 and our hypotenuse is 6. What do you notice as the relationship between the short leg and the hypotenuse? Each time we're multiplying the short leg times 2 to get the hypotenuse. So this is going to help us with the parent triangle in the next slide. Next, I want you to notice the relationship between the short leg and the long leg. So again, here's the short leg, and here's the long leg. When our short leg is 6, our long leg is 6 radical 3. The long leg is always opposite the 60-degree angle. That's our middle, our medium size. Remember, the hypotenuse is always the longest side. The side opposite the 30 is the shortest side, so the side opposite the 60 is the medium side. Now, we know that in a right triangle, the sides not called the hypotenuse are the legs. So again, we're going to refer to the side across from the 30 as the short leg, and the side across from the 60 as the long leg. Here, our short leg is 4, and our long leg is 4 radical 3. Here, our short leg is 3, and our long leg is 3 radical 3. So each time with each triangle, we're multiplying the short leg by the square root of 3 to get the long leg. So let's take a look at the vocab and fill in our parent triangle. So the parent triangle of a 30, 60, 90 triangle. So remember, anytime we have a right triangle, that's going to have a 90-degree angle. So here is a 30, 60, 90 triangle. We know that the side opposite the right angle is the hypotenuse. The side opposite the 30 is the smallest side, which of a 30, 60, 90 triangle, we're going to refer to as the short leg. And the side opposite the 60 is the medium side, which we're going to refer to as the long leg. So if the short leg of the 30, 60, 90 triangle has a measure of 1, using what we just saw on the explore side, we multiply the short leg by 2 to get the hypotenuse. So the hypotenuse is going to be 1 times 2, which is going to give us 2. And again, referring back to the explore problem, in order to get the long leg of the triangle, we multiply the short leg by the square root of 3. So 1 times the square root of 3 is just the square root of 3. So for the parent triangle of a 30, 60, 90 triangle, the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. So these are the numbers that we're going to refer back to help us set up the ratios to find the missing sides of a 30, 60, 90 triangle. Okay, so for GP number 1, this is our new triangle. If you remember back in the previous lesson, when we set up the chart, the new triangle will go on top and the parent triangle will go on the bottom. For this triangle here, we're going to have the short leg, the long leg, and the hypotenuse that we're going to identify. So for this triangle, again, the hypotenuse is always across from the right angle. That is the longest side of your triangle. So our hypotenuse in this case is M. For our angles, we already have the 60 and the 90, therefore this angle here must be 30. The side opposite the 30 is always the shortest side of your triangle. So the short side of my new triangle is going to be the square root of 5, which leaves me the long side, the long leg, which is opposite the 60, and that is N. So we're looking for the missing sides. We're looking for both M and N in this case. For the parent triangle, our short leg is 1, our hypotenuse is 2, and our long leg is the square root of 3. 1, 2, radical 3. So we set up our ratios. Again, we have to begin with the ratio that we don't have a variable in, which is going to be the short leg. That one has to be used in helping us find the other sides. We have the square root of 5 over 1 is equal to, and I'm going to go ahead and solve for n first, n divided by the square root of 3. We cross multiply. 1 times n is equal to the square root of 5 times the square root of 3. Because both of these values are inside the radical, I can go ahead and multiply those values together, giving me the square root of 15. Now we want to make sure that we check to see that our radical can or cannot be simplified. So if I were to break this 15 down, I would have 3 and 5 with no pairs, indicating that this is the simplest radical form. But we have to make sure that we're checking for that, because there have been times where I've seen work turned in where the radicals are not simplified. So make sure we're always checking to see that that radical can or cannot be simplified. Then to find m, we use the same ratio, the square root of 5 divided by 1 equal to, in this case, m over 2. We cross multiply. 1 times m is equal to the square root of 5 times 2. Now in this case, we have one inside number, one outside number. We cannot multiply those two values together. So we will just simply take the 2, and it will be a coefficient on the square root of 5, giving us an answer of 2 radical 5. So we're going to set up our ratio, short leg, long leg, hypotenuse. Remember the parent triangle is 1, 2 for the hypotenuse, and rad 3 for the long leg. We have to always start with the ratio that we have no variable in, which is the square root of 5 over 1 in this case, and set it equal to both of the other two proportions or ratios separately to find those missing values. I want you to go ahead and pause the video and work through this question here, and let's see how you do. All right, let's see how you did with this one. So we have the short leg, the long leg, and the hypotenuse. New triangle on top, parent triangle on the bottom. The short leg here is going to be 7. The long leg is V, and the hypotenuse is U. Our parent triangle short leg is 1, hypotenuse is 2, and the long leg is the square root of 3. We have to use what ratio does not contain a variable first, so 7 over 1 is equal to, looking for L first, I'm going to do V divided by the square root of 3. I'm sorry, looking for V first, which is the long leg, V divided by the square root of 3. If you cross multiply, you get 1 times V, which is V, is equal to 7 times the square root of 3. We cannot multiply those two numbers together because one is outside, one is inside. Therefore, this is our answer. For U, using 7 over 1 again, 7 over 1 is equal to U divided by 2. We cross multiply. 1 times U is U, and 7 times 2 gives us 14. Right, so in these two cases, we were given the short leg of the triangle. Let's take a look at a few more, given different side values. So for this triangle here, the side we're given is opposite the right angle. Therefore, that is the hypotenuse of our triangle. We're going to set up our chart. We have the short leg, the long leg, and the hypotenuse. For the new triangle, the short leg here is going to be side B. The long leg is side A, and the hypotenuse is 4 radical 3. For the parent triangle, the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. This contains a variable, this contains a variable, this one does not. So 4 rad 3 over 2 is the ratio that we're going to have to use to solve for our missing sides. So we begin with 4 radical 3 divided by 2 is equal to, let's go ahead and find the short leg first, b divided by 1. Now remember, anytime you have a variable divided by 1, that's just going to equal your variable. So b divided by 1 is simply just b. So b is equal to 4 radical 3 divided by 2. Now if we can simplify this, we want to. Let's take a look at our outside numbers. 4 and 2 are both divisible by 2, and that's going to simplify to 2 radical 3. For the long leg, using 4 radical 3 divided by 2 again is equal to a over radical 3. When we cross multiply, we get 2 times a is equal to 4 radical 3 times radical 3. If we simplify this, radical 3 times radical 3, our radical is going to go away and leave us with just 3. Giving us 2a is equal to 12. Then we will divide both sides by 2 to get a by itself, giving us an answer of a equals 6. All right, let's have you guys try this one out. Pause the video, take a minute to work through this one, and then come back and we'll see how you did. So when you set up your chart, you have your short leg, your long leg, and your hypotenuse, your new triangle on top, your parent triangle on the bottom. For our new triangle, our hypotenuse is 8. Our short leg is y, and our long leg is x. For the parent triangle, short leg is 1, hypotenuse 2, long leg radical 3. So we have to use the ratio we're given both values for. That's going to be 8 over 2 is equal to, go ahead and find the short leg first, y over 1. That's going to leave us with just y equals 8 divided by 2, which we know is equal to 4. Again, using 8 over 2 is equal to, for the long leg, x divided by the square root of 3. We cross multiply, we have 2 times x is equal to 8 radical 3. Divide both sides by 2. Simplify those outside values, and we get 4 radical 3. And this is solving given the hypotenuse. Lastly, we have solving given the long leg. So once again, we're going to start with our chart. For this one here, the long leg is 12. the hypotenuse is x, and the short leg is y. From our parent triangle, the short leg is 1, hypotenuse is 2, and the long leg is radical 3. The ratio that has no variables is the long leg ratio, so we have to use that one to solve for our other two missing sides. So for the long leg, 12 divided by the square root of 3. I'm going to go ahead and start with the short leg equals y divided by 1. Y divided by 1 leaves us with just y equals 12 divided by radical 3. Remember, we cannot leave radicals in the denominator. We must rationalize. So here we're going to multiply by radical 3 over radical 3, which will give us 12 radical 3 divided by 3. We can simplify those outside numbers. 12 divided by 3 is going to give us 4 radical 3. Going back to my chart, using the ratio we're given again, 12 divided by the square root of 3. Now to find the hypotenuse, x divided by 2. We cross multiply. X radical 3 is equal to 12 times 2, which is going to give us 24. We divide both sides by the square root of 3. And we're going to rationalize this. So we multiply by radical 3 over radical 3, giving us 24 radical 3 divided by 3. Simplify those outside values, 24 divided by 3, and that gives us 8 radical 3. So again, this is solving given the long leg. I'll give you one more question to try. Please push pause, work through this question, and come back to see how you did. So in your chart, you have your short leg, your long leg, your hypotenuse. For the new triangle, the short leg is v, the long leg is 7 radical 3, and the hypotenuse is u. For the parent triangle, our short leg is 1, hypotenuse 2, and the long leg radical 3. Using the ratio that contains no variables, 7 radical 3 divided by radical 3 is equal to, here, v divided by 1. V divided by 1 is going to simply equal v. And if we simplify 7 radical 3 divided by radical 3, that's going to leave us with 7. And then for the hypotenuse, again, if you see that you can simplify this ratio, feel free to go ahead and simplify that ratio. So that's going to leave us with 7 equals u over 2. Now you can cross multiply here, that works as well. But if we do it this way, there's less steps, less work, and we get u is equal to 14. So that is an option. Now, if you cross multiplied here, you would have gotten u radical 3 equals 14 radical 3. You divide both sides by radical 3. And you end up with the same answer. So make yourself a note that if you see that those ratios can be simplified, by all means, you can simplify that ratio. And that is the second and last of our special right triangles, 30, 60, 90. Remember, short leg is 1, hypotenuse is 2, and the long leg is radical 3. Be sure to answer your essential question.